In this video, we will look at the meaning and differences between binomial distribution, Poisson distribution and normal distribution. What is binomial distribution? Let's start with an example. Imagine you toss a coin 10 times and want to know the chance of getting exactly 6 heads. Each toss has 2 outcomes, right? Head or tail, and we count the number of successes, like heads. That's binomial distribution. Key idea is these are yes-no type outcomes, repeated a fixed number of times. Practical application of binomial distribution in the case of exams: out of 20 multiple-choice questions, each with right or wrong, what's the chance you get 15 correct? Let's look at another example. In sports, probability that a basketball player makes 7 out of 10 free throws. Now let's look at Poisson distribution again. Let's start with an example. You are standing at an ice cream shop, and you count how many people come in during 1 minute. Some minutes may have 0, some 1, some 2, etc. But on average, say 2 people per minute come. That's Poisson distribution. Key idea is counting how many events happen in a fixed time or space when they happen at a certain average rate. Practical application of Poisson distribution: how many phone calls come to a helpline in an hour? How many typing mistakes you make per page while writing fast? Between binomial and Poisson, in the case of binomial, it counts how many successes you get in a fixed number of yes or no trials. Under Poisson, we count how many times an event happens in a fixed interval of time or space, when events happen randomly but with a certain average rate, lambda. We don't fix the number of trials. Now let's look at normal distribution, also known as bell curve. For example, suppose your whole class writes a math test. Most students score around the middle, say 50 marks, fewer score very high 90 plus or very low 10. When you draw this as a graph, it looks like a bell shape. That's normal distribution. Key idea is these things that naturally cluster around an average, with fewer at the extremes. Some practical application of normal distribution. O height of students in your class, most around average, few very short tall. O marks in an exam, most near average, few toppers failures. O IQ scores, weight, shoe sizes. So, if you toss coins is equal to binomial, if you count rare events over time is equal to Poisson, if you measure natural variation is equal to normal. A binomial distribution itself is not a histogram, it is a probability distribution. But when we draw the binomial distribution, we often represent it as a bar graph that looks like a histogram. Histogram shows observed data, what you actually got from an experiment. Example: you toss a coin 10 times and repeat this 50 times, then count how many times you got 0 heads, 1 head, 2 heads, etc. That bar chart is a histogram. Binomial probability distribution shows the theoretical probability of each outcome, what math predicts. Example: the probability of getting exactly 6 heads in 10 tosses is 0.21. If you plot all these probabilities, 0 heads, 1 head, up to 10 heads, you get a bar chart that looks like a histogram. Think of it like this: histogram is equal to what really happened, binomial distribution plot is equal to what math says should happen. Now let us see how binomial, Poisson are used in machine learning. We will start with binomial distribution. Classification problems: logistic regression assumes outcomes are Bernoulli, special case of binomial with n is equal to 1. Evaluation metrics: when counting how many predictions are correct, success, failure. Modeling binary outcomes: example, did the customer click the ad? 1 in the case of yes and 0 in the case of no. Email spam detection. Each email is success, failure, spam versus not spam. A/B testing. Number of users who clicked button A versus button B follows binomial. Predicting loan default. If default, it is 1 or not a default, it is 0. Where Poisson used in machine learning: count data problems, Poisson regression models how many times something happens. Time series event prediction, used when predicting events per unit time. Practical examples: example 1, predicting number of customer support calls in an hour. Example 2, modeling number of purchases per day in an online store. Example 3, Accident prediction. That is how many accidents occur at a traffic signal per week.